Hi, this is Alex from devstories.eu. Deep Agents, Episode 5 of 16. Most AI agents crash or fail silently the moment they read a system log or a data dump that exceeds their maximum prompt size. Deep Agents prevents this by treating context limits like an operating system handles virtual memory. This is called context compression and offloading. Large language models have a hard ceiling on how much text they can process at one time. If an agent tries to hold too much data in its active prompt, the model throws an error and stops. Deep Agents manages this token overflow by constantly monitoring the size of the conversation data. It works exactly like a computer paging RAM to a hard drive when memory gets full. The active working space is kept lean, while the bulk data is moved safely out of the way. This mechanism operates in two distinct phases. The first phase handles immediate massive data spikes from external tools. The framework watches the token count of every single tool input and tool result. The hard threshold for this check is 20,000 tokens. If an operation exceeds this limit, the system intercepts the payload before it ever reaches the language model. Consider an agent executing a query that pulls a massive 30,000 token database dump. A standard agent attempts to insert that entire payload straight into the conversation history, which immediately triggers a token overflow. Deep Agents takes a different route. It intercepts that massive response, offloads the full text into a new file on the back-end file system, and replaces the payload in the conversation with a simple 10-line preview. The agent reads the preview and receives a file path pointing to the complete data. The agent knows exactly what it found, but the active prompt remains completely uncluttered. That handles sudden data spikes. The second phase handles the slow accumulation of a standard conversation. As an agent runs a long, multi-step process, the continuous back-and-forth history slowly eats up available tokens. Deep Agents monitors the total context window usage against the model limits. When the active prompt hits 85% of the total available context window, a background summarization process triggers automatically. The system takes the oldest block of messages in the current history and uses the language model to generate a dense, factual summary of those events. It then replaces that older block of messages in the active prompt with the newly generated summary, instantly dropping the token count back down to a safe working level. Here is the key insight. Developers often assume that summarizing the conversation permanently destroys the original history. That is not true. Before any summarization takes place, the original messages are written to the file system as a permanent canonical record. The raw data is not lost. If the agent later determines it needs a highly specific detail from an earlier step that did not make it into the summary, it can use its search tools to query that file system and retrieve the exact original text. By pairing immediate file system offloads for massive tool results with dynamic summarization for long-running histories, an agent can operate indefinitely without suffocating on its own context. Thanks for listening. Happy coding, everyone.